Okay, so we're gonna be finding the gain of this circuit. So right now I'm just using variables for everything. I'm just gonna be showing the step-by-step process of how we're gonna be finding gain, and this is assuming we have all of our DC analysis currents available to us, especially IC, since we'll be actually using IC to find our GM, because GM is equal to IC over VT, and VT is a constant, which would be equal to 0.25 or 0.26 millivolts. Okay, so with that being said, we can get started. I'm actually going to be writing out the formula real quick as well. So we're also going to have GM is multiplied to VBE, and I think this is all we're gonna need for now. Okay, so now what we're gonna do is actually convert this circuit. This circuit has the DC components and AC components active. What we're gonna be doing is turning this into an AC analysis problem. This is once again assuming that we already have all of our DC components. And to start off, what we're going to be doing is shorting all of our AC components and also disconnecting all of our DC sources. So for example, this will be shorted into a line, same with this, and same with this. So now that we have that, we're going to be remaking the circuit as a AC analysis problem circuit, whatever you want to say. So we're gonna have our VSIG. This is a AC supply. We're gonna have our resistor RSIG, and then this capacitor is gonna be shorted. And then we're also gonna have our RB, which is connected to ground. Oh, give me 1 second. There we go. So RB. And then we're also gonna have a hybrid pi model for this. The reason I'm doing hybrid pi is because our emitter right here is connected to a ground directly. This even works if we have a resistor as well, like say over here. If we had a resistor, it would still work, although the steps may vary a little bit. But yeah, so I'm gonna be doing the hybrid pi. So to do the hybrid pi, we're gonna replace our BJT with the hybrid pi model, which looks like this. We're gonna have our resistor, which is gonna be written down as R pi, and then we're gonna have our emitter is gonna be right here, and it's gonna be connected directly to ground. And then we're also gonna have our collector, this part of our circuit, connected over here. And before we draw that part of the circuit for the hybrid pi model, we're also going to have a dependent current source over here. Okay, so we're going to draw that and that. And in our case, our dependent current source is going to be flowing to the left. So like this, going down like this. Our current is going to be flowing towards the left. So that since it's flowing to the left, it's going to be flowing down here into the emitter, or towards the emitter. And this is going to be known as GMVBE. And then, so then we're also going to have our two resistors in parallel. We're going to have this resistor, which is actually, I forgot to label this. This is RC. Oh my god. RC. So now we're gonna have our resistor over here, and this is connected to ground since we have shorted / opened up this source. So it's connected to ground now. And we'll just label this as RC over here. And then we also have our R load, which V out is across. So we'll connect that over here directly to ground, since it is grounded right over here. So this will be R R L, and V out is across this resistor. We're also going to have our VB, and we're also going to have our VE. So the reason these are called VB and VE are because this is our base over here, this side, and this over here is our emitter, and this over here is going to be VBE. So the voltage drop across this R pi is going to be VBE. Okay, so now that we know that, we can say that our V pi, which is technically also equal to VBE, is going to be equal to RB pi. That is because these two resistors are in parallel. So RB in parallel with R pi is going to equal to, gets very annoying, is going to be RB pi. So now that we have RB pi, what we can do is actually make our equation for this voltage drop across, right, this resistor over here. So now let's continue making our equation. We're also going to have our RB pi plus R sig, since this R sig is going to be in series with these two resistors. Okay, so as you can see already, I'm actually making a voltage divider right here. So now if we look over here, this V sig is going to be multiplied by RB pi, which is these two resistors in parallel, divided by RB pi plus R sig. So with that being said, we have our VBE. So once you solve this, it'll give you your answer to VBE. So there you go. We've solved for VBE. We've gotten one part of the solution done. So now what we also need is our GM. Now GM is just IC over VT, and IC we get by calculating the collector current right here using the DC analysis. This will be open circuit, and we're literally just taking the current flowing down from here, and that'll be equal to our IC. And it is flowing down in our case, so for that reason, that like I explained before, we have our voltage or current pointing down. So now, assuming that we have IC, we can calculate our our GM. So now we have GM. So now that we have calculated this dependent current source, we know that that current is also flowing right here, GMVBE. And our VO is going to be equal to, these two resistors are in parallel, so we're going to do RC is in parallel with RL, and then if we multiply GM V pi slash VBE by this, we will actually get our V out. So with that being said, we've calculated, this is our equation to find V out. Also, one more thing, this over here will actually be a negative. The reason it's a negative is because this current is flowing out, and we have a positive polarity over here. So since it's flowing out of the positive polarity, that means that the current flowing will be negative with respect to the RL polarities. So now that we've found this expression over here, what we can actually do is divide out our V pi and then keep our, actually, you know what I'm gonna do? I'm gonna actually rate this as RCL, the whatever the parallel combination of these two is, and then what I'm gonna do is multiply this by GM. So if we take a look over here, we've actually found VO over V pi. Now another cool thing that we actually have is v pi over v sig. So we've actually already found v pi over v sig, and that is going to be equal to this expression over here. And the reason I'm saying that is because now what we can do is we can actually take this. I'm just going to rewrite this as v pi. Now what we can actually do is we can write v pi over v sig is going to be equal to rb pi plus r sig. So if you guys don't see it already, what we've pretty much done is we've made v o over v pi, and we've also made v pi over v sig. And what's so cool about this is we multiply these two, we can just cancel out the v pi's, and we end up getting vo over v sig. So that is going to actually be our answer. So this expression and this expression are just going to be put over each other. So RCL multiplied by GM is going to be over RB, whatever this expression is over here. Let me just quickly erase this and make some space. And there we go. This will be our gain. So once you end up solving this, you will be able to get a V.